In this optimization problem, we're designing a poster with margins that allow the printed area to be as large as possible. I think this is one of the hardest optimization problems to do. I'm going to explain things really clearly so that by the end, you will know exactly how to solve this type of problem. The first thing we want to do to solve this problem is to read through the problem carefully and figure out what information we're given and then what we're asked to find. We are told that a poster is to have an area of 180 inches squared with 1-inch margins at the bottom and sides and a 2-inch margin at the top. I went ahead and drew a picture of this just so that you can see what that looks like. We're asked, what are the dimensions of the poster that will give the largest printed area? Our second step is to fill in this chart that I've listed, and we'll start with the one on the left, the diagram and variables. We want to find eventually the dimensions of the poster. That's going to clue us in that we need to make the width of the poster equal to a variable x and the height of the poster equal to a variable y. Let's write that down. X is the width of the poster, and then y is the height of the poster. Now let's go ahead and let's put our margins into our picture. Up in yellow, I have highlighted that we have 1-inch margins at the bottom and the sides. So let's just mark that this is 1 inch. This is 1 inch. We'll squish it in there. And then this is 1 inch. And then our top margin is 2 inches. Now what we want to do is we want to write down an equation that relates our diagram to other information that we've been given. We are told that the poster is to have an area of 180 inches squared. So we can say that our area of our poster is x times y, and that is 180 inches squared. Now let's go over and figure out what we want to maximize or minimize. We want to find the largest printed area. The printed area is the part inside here, and I'm going to label that as PA. So that's what we want to maximize. So let's write down that we want to maximize our printed area PA. Now what we have to do is get an equation for PA. Let's do the width first. This width here is going to be x minus 2 because we have 1-inch margins on each side. And then this height is going to be y minus 3 because we have a 2-inch margin at the top and 1 inch at the bottom. We can then say that our printed area PA is equal to our width, which is x minus 2, times our height, which is y minus 3. Now, we are going to take the derivative of the printed area so that we can maximize it. And we only want to do this if it's in terms of one variable. So let's go back to our equation and let's solve our equation for y and plug it in right here. Y is equal to 180 divided by x. Let's now put that in. PA is equal to x minus 2 times 180 divided by x minus 3. We have to take the derivative of this, and I think it's going to be complicated to find if we leave our printed area in that form. So let's go ahead and let's use the FOIL method and multiply these two quantities. Our printed area, and let me write FOIL up here because that'll help us, FOIL. The first terms are x times 180 divided by x, so that's just 180. And then we're going to multiply the outer terms, and that gives us a minus 3x. And then our inner terms give us a minus 360 over x. And then our last terms are plus 6. And we can rewrite this and combine the 180 and the 6. So we have 186 minus 3x minus 360. And then let's write this as x to the minus 1 because it'll be easier to take the derivative. I'm going to highlight this because we are going to need to be able to go back up and find this. Let's now think about our domain. We are not given any constraints on how big or small the poster can be. We do know, however, that x can't be 0 or less than 0. So let's write our domain is x is greater than 0, and this is an open domain. We're going to need to know that when we go to justify our answer. Our third step is to take the derivative of our printed area function, find the critical values, and then find the maximum value. Let me go ahead and let's write down our printed area function again. This is 186 minus 3x minus 360x to the minus 1. And now let's go ahead and take the derivative. I'm going to write this as PA prime, and this is minus 3 plus 360 x to the minus 2. We are going to need to set this equal to 0, so let's simplify it. This is minus 3 plus 360 all divided by x squared. Let's get a common denominator of x squared. So this gives us a minus 3x squared plus 360 in our numerator. Now we're going to set this equal to 0 to get our critical values. Notice that we could have a critical value at 0 because our denominator is equal to 0 when x is 0, but our function isn't defined at 0, so we don't have to worry about that. We just have to worry about the numerator being equal to 0. This gives us 3x squared is equal to 360. So x squared is equal to 120. And this gives us x is the square root of 120. Think of 120 as 4 times 30. So we can pull out the square root of 4 as 2. So we have x is equal to 2 square root of 30. And then we need units. So let's go back up. Everything is in terms of inches. So we can write down inches. Let's go ahead and let's highlight that. So that's x. Now we need to find y. We have an equation for y hiding somewhere. Let me go ahead and highlight it. It is right here. 180 divided by x. So let's write down that y is 180 divided by x. So this is 180 all divided by 2 root 30. This then is 90 divided by root 30. And I think we should go ahead and multiply by root 30 over root 30. This is going to make things easier. So this gives us that y is equal to 90 divided by 30, which is just 3, square root of 30. And again, we have inches for our units. Now what we have to do is find the maximum printed area. Let's go back up here. Notice that we have 2 equations for PA. Let me put a check by these. We have this one and this one. I think the first one, x minus 2 times y minus 3, is going to be the easiest one to use to find out what PA is. So let's write down that PA is x minus 2 times y minus 3. And now let's substitute in for x and y. X is 2 root 30. So we have 2 root 30 minus 2. And then y is 3 root 30 minus 3. Let's go ahead and use the FOIL method and multiply all of this out. Our first terms are 2 root 30 times 3 root 30. So this is 6 times 30. And then our outer terms gives us a minus 6 root 30. And then our inner terms is the same thing, minus 6 root 30. And then our last terms gives us a plus 6. So our printed area is 180 plus 6. So that is 186 minus 12 root 30, not a nice answer, inches squared. And we'll go ahead and let's highlight that. Now, it might feel that we're done, but we're not quite done yet. What we have to do now is we have to justify if the answer that we just got is a maximum. Let's go ahead and let's look back up here. This expression right here is our first derivative. We can use the first derivative test or the second derivative test for our justification. Honestly, I don't think it matters for this problem which one we use. I think they're both complicated. I am going to choose to use the first derivative test. So I'm just going to put down what our derivative is. PA prime is minus 3x squared plus 360, all divided by x squared. We want to find if our derivative is positive or negative to the left and right of our critical value. Because our denominator is an x squared, we really just have to look at the numerator. Let's go ahead and let's draw a number line. And we'll put x on this. We'll remind ourselves that it is an open interval starting at 0. And let's put our critical value, that is 2 root 30. To the right of our critical value, as x gets really, really large, we just have to look at the leading term. That is negative. So we know that this is going to be negative. And then if we pick a point to the left of 2 root 30, say 1, we get that our derivative is positive. This tells us that our function, which is our printed area, is increasing and then decreasing. So we do have a max at x is equal to 2 root 30 inches. And our max is equal to PA, which is our 186 minus 12 root 30 inches squared. Now, the last thing that we have to do is to reread our problem and then carefully state our final answer in a complete sentence with units. Let's go back up to the top. We want to find, up here in green, the dimensions of the poster. So let's go ahead and let's state that. Step 5, we're going to say that the width is 2 root 30 inches and the height is 3 root 30 inches. And that's our final answer.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.